You can have it. Okay, so we are recording and we are live on Facebook in just about some seconds. Great. So hi everyone. I'm going to start in Spanish so we are all clear about all the instructions, and then I'm going to switch to English back again so I can introduce Ana. Así que hola a todos, muy buenas tardes, gracias por estar desde temprano ya en la sala de attendees. Mi nombre es Fabi Velarde y soy parte del equipo de FERLAC Jalisco, trabajando desde el componente de emprendimiento. Nos da mucho gusto estar en esta charla sobre inteligencia artificial con Ana. Creo que va a ser algo súper interesante y va a estar lleno de tópicos muy valiosos para la actualidad. Les comparto que al finalizar la sesión tendremos unos minutos para preguntas y respuestas, y estas las pueden hacer en la sección de Q&A que está aquí abajito de sus pantallas, y también a través de la transmisión en Facebook que está ahorita en vivo. Pueden poner ahí sus comentarios en la sección de comentarios. Antes de iniciar, me gustaría compartirles un breve video sobre qué es la iniciativa de FERLAC Jalisco. Y espero que se oiga, creo que no se va a oír, así que voy a volver a compartir. Ahora sí, ya.
FERLAC Jalisco es una iniciativa liderada por el Banco Interamericano de Desarrollo, el Tecnológico de Monterrey en Guadalajara, el Gobierno de Jalisco y C-Minds. FERLAC Jalisco trabaja a través de la articulación de academia, sociedad civil, sector público y sector privado en 3 componentes. 1. Es la implementación de soluciones tecnológicas mediante técnicas de inteligencia artificial para resolver problemáticas sociales en Jalisco. Otro es la recomendación en creación de política pública para el uso de inteligencia artificial, así como el impulso del uso ético y responsable de esta. Y el tercer componente es el fortalecimiento del ecosistema emprendedor local de inteligencia artificial responsable. FERLAC Jalisco forma parte de uno de los hubs de FERLAC que tienen presencia en Medellín, Colombia, Costa Rica y Uruguay. En Jalisco se cuenta con un diferenciador único, el componente de emprendimiento que busca fortalecer al ecosistema emprendedor en IA a través de actividades como el programa de aceleración de startups de IA PASIA, IA Talks, talleres de integración de inteligencia artificial responsable y de Venture Capital, hackatones y el análisis del ecosistema jalisciense de emprendimiento en inteligencia artificial. FERLAC, por un uso ético y responsable de la inteligencia artificial.
Y bueno, antes de dar la introducción y cambiar otra vez al inglés, les recuerdo que en esta charla pueden poner sus preguntas y respuestas, sus preguntas aquí en la sección de abajo. Pueden ponerlas en español, nosotros les vamos a poder ayudar a traducirlas si es que quieren de esa manera exponer un poquito mejor. And well, we're going to change back in English. And so I'm going to give our speaker a great welcome. She's Ana Azadevik. I hope I say that well. Ana is an engineering manager for AI projects in Nextivia. She has been with Nextivia since December 2018 and recently moved to the US from Ukraine. She has profound experience in software development management, staffing, and mentoring. Deep knowledge of system architecture, object-oriented design, service-oriented architecture, managed machine learning systems, big data architecture, successful experience in promoting companies' revenue teams, and in KPIs. Welcome, Ana. I'm really happy to have you here. We're really excited to see what you have for us. And well, the mic is all yours.
Hello, hi everyone. Thanks for inviting. It's an honor, and I'm very inspired to share all interesting stuff that we've made and built in Nextiva. And as you guys know, everything which is in these days connected with AI, it's pretty interesting topics like new technologies and etc. and looks quite promising, and it also something that could make our lives easier. So one of the things that we were making in Nextiva as part of AI projects, it's voice transcription. So today I will cover some of main topics that could bring you more interesting details on what we built, how it's working, and what technologies we were using. So agenda for today is that I will start with speech recognition, like how it's working, what technologies were used in the past, what are like interesting things and up-to-date technologies and framework that we are using for our solution. Also, I will share our journey of building transcription model and solution around it, because as you maybe know, like not all AI solutions, they are going like from POC MVP phase to be like an enterprise solution, something that you put on production into your system, and it's always a journey. So we can say that it's something that we did like, in the first day or first month for our project. The next one, I'll be covering like Wave to Web 2.0 architecture. It's how the model works, what makes it so special, and why they decided to go with this model. The next one will be how we build our architecture. So besides the model for all AI solutions and for delivering your models and everything that you've done, like looks good, for example, on your local machine or on the environment, it's just like one step in the journey, because you need to embed it into existing system, make services around it, integrate it with existing components, because by this one, you'll only have benefits and features from it, because like just having like a cool model running on your local machine is only one piece of a puzzle. So I will be covering how we've embedded it to our architecture and to our application. The next one is performance analysis, because for each AI solution, for each AI project, it always comes to the question like, what is the accuracy? What are performance results, and etc. So I will be sharing results that we've received in our transcription project and comparing it with other third-party solutions and the solutions that we were using previously in Nextiva. And also besides that, I will share like our plans and next steps, what we are planning to do for transcription. What are our next steps on building, the next phases of this project. And the last one, but not like the least based on importance, it's I will show example how on the basis of one of voicemails that were sent to me in my personal account, how transcription performs, and we'll compare accuracy of transcription made by our solution and with third party. So this is agenda for today. So let's start. So like once you hear someone like talking and saying, what is this speech recognition? Like what is this voice recognition or voice to text? These are all synonyms that help you to describe one problem. And what is this the problem about? Problem is transcribing raw signal with any kind of speech recognizers to recognize text. Speech recognition, it's like putting in the same, like putting based on the audio, the text that was said in this audio. Like, why is this so complicated and why this problem is so important? So as we know, there are a lot of languages besides English language that has like different structure, and people, if like also talking like English, they have like specific pronunciation, accent, the speed of talking, it also varies. So these are all factors that influence speech recognition. And besides that, once you're talking, there could be multiple people talking at once, or there could be noise on the background. So these are also things that influence the quality of your recognition of the speech. And as you maybe know, this like problem of defining like what the text was behind the speech, it wasn't the like interesting thing to investigate like just these years. These problems was raised before because humanity as well were concerned about how to talk to like to machines, how to make like machines understand our language and so on. So it's also all like puzzles of a big problem and of a big idea. So make like one language of interaction and make voice commands with just your speech. So recognize text, and once you solve this problem and you have voice transcription, it's a key to many projects. So it's not just like voice commands that you can have and review right now, having like as Alexa Home or Siri. So it gives you and enables you like possibility to say just few simple commands to your phone or to AI system, and it will be helping you with simple things that you will not need to spend time for. But besides this, voice transcription opens the door for other features, like you could analyze text. Once you have all your calls or voice messages as a text, you could easily search through them. So it will give you more ability and understanding what were the conversations, summarizing them, making action items for them, bullet points, and enabling throughout search of all your text messages, voice call transcriptions, voice call recordings, and etc. So the problems about speech recognition and how do we do it, it was in investigation like for many years. Not just recently, and the problem from like math perspective and from technical perspective, it could be described in the following way. So what is this speech recognition task? So for example, like you are speaking some sequence of words, is the vector of W. And there are some kind of O is a vector of observations. It's O1, O2, and etc. So the problem could be formulated from math perspective, how to find W vector based on O vector. So interesting thing also why we call that O is observations, you know, not like a signal and etc. Because besides like speech that you hear, there is also an observation includes also noise, some like external, I don't know, like breathing of a person, you know, like pauses and etc. So observation is the whole complex of variety sounds that you need to understand, analyze, and get from it and get the text out of it. So that's why we are speaking more to observation. So the problem is, how do we find W based on our O, based on observation? So how do we find it and how do we do that? So, but like already math gave us how to solve this speech recognition task. So based on probabilities with which you are like listening, with which you hear observations, and with which you could put the words into the relevance of what you hear, we could use the following formula. From the first part to the second part, we are opening it via bias rule. And from the second part of equation to the third one, since once you divide on something, it doesn't influence for maximization of the product of values, so we could just keep it and concentrate on the right part of the equation. It's argmax of multiplication of probability of observation when the specific words were speaking, multiply on probability of this word in the sentence. So it's like how pure math states on what and how do we need to solve this problem. So this is like equation describes the answer on the questions that we raised on the previous slide. So this is how we solve it. Interesting thing that for each part of the right part of equation is responsible like separate components, major components in the speech recognition system. So the most right one is probability of W. For this one is responsible language model. So it depends like on what language we're speaking, then the probability of each word appear in your sentences will be based on a language model. More to left side, it's probability of observations where specific words were spoken. So for this one, it's acoustic model is responsible for that. These are two like main parts that you could see in most of the speech recognition systems. And the maximizations of the product of these two values, it's a decoder. So the decoder like gets the whole magic and gets the maximum of this product. So once it gets the maximum of this product, it gets the most like proper and the best answer for what the words were speaking like based on the observations. So let's go to the next one. In general, during the history for solving speech recognition problems, besides neural networks and building automatic speech recognition, there were different approaches of solving it. So from the first time, there were dynamic time warping methods. They were invented like before 80s. And they were like pretty used like they were used in most of the systems that were trying to solve this problem. But most of the systems, they were more bounded, like you could train it only on one person's voice. So they didn't have invariance to the people's like voice, accents, and different speed of pronunciation of the words. Later, hidden Markov model was used and like were tried to apply it for solving also speech recognition problems. And from the like 2000s years, there were practical speech recognition methods, like such as neural networks as well, that were used for solving this problem. So as you can see, during the history, people were trying to solve this thing because it will give ability to like talk to machines, make another useful features. So it's just something that everyone like dreamed to have like in the application and like access to it. So let's speak about like how modern automatic speech recognition system works. What are the main components of that? So as you know from the formula, like from the previous formulas that we were discussing how math problem is formulated. So once we have like a speech as an input, then we are working on feature extraction of this speech, passing it to acoustic model. Besides that, we are having lexicon and language model. And based on these components, what we put in the search space, the decoder makes like a maximum of multiply of these products. And that's how we are receiving the vector of words as our output. So it's just a response of what was said during the speech. So these are components that are usually you can see in modern automatic speech recognition systems. And sometimes some of these components could be absent, such as like lexicon and language model. So the decoder will be taken into consideration only what acoustic model gave in response. But like acoustic model, it's like the main component without which like any automatic speech recognition system couldn't resist, because like it's analyzer and matching components that gives like match your phonemes once you speak into like into the sequence of these phonemes and gives probability of each one. So without acoustic model, we can't say that like any ICR system could exist, but without lexicon and language models, there are some cases that automatic speech recognition could take place. So let's start and discuss like I wanted to share what were our Nexiva's transcription model journey. So like what was our first option to try? We were just like investigating and analyzing how do like other companies do voice transcription, like because for nowadays there are a lot of open source libraries projects that like if you have I don't know, like basic knowledge and willing to understand neural networks, so you could reuse them and adopt them for your system needs. So we figured out that there was, and there is right now, Wave to Letter project. It's written in C++, and it was made, implemented by Facebook team, and exposed as like an open source for everyone who could want to try it. Besides, like, how do we started? We were just trying to build the project, build and run Wave to Letter locally. It was in C++, and it had like a lot of, you know, surprises once you work with C++ and you're not doing it daily. So it was pretty challenging for our team. Sorry, lights just turned off. Okay, so we used, sorry, just 1 second. Okay. So after we built the project for Wave to Letter, we wanted also to try to train it. But one of the main difficulties for using Wave to Letter was if you want to train it, you need to have like a bunch of data, a bunch of labeled data that you would like to train your model on. And besides having this labeled data, you need to have capacity, like as you know, big companies have like a lot of like GPUs, powerful GPU clusters that you could train your model like for a month. But we didn't have that. We just built that, tried to like train it, understand how it works. And we didn't have those like kind of, you know, like lots and tons of labeled data. Because like once we have also calls and voicemails, in order to have it labeled, you need to transcribe that. If you want to transcribe that, you could just use like some kind of, you know, open source, transcribe that, but actually without manual input, without someone who could recheck, you know, like if the transcription is correct or not, you couldn't use that for training. And this one especially is critical because for rechecking and for manual transcription, it requires like a lot of hours of manual work for that. And also for measuring accuracy of the transcription, you need to have like original transcription of what was the person is speaking about. If you don't have original transcription, like you can't train on it, and you can't measure accuracy of your model, because accuracy is measured based on the etalon, based on the 100% accuracy of voice call transcription or voicemail transcription. So, and besides that, we were also checking performance metrics of Wave to Letter model. Performance was for Wave to Letter model was built inference by Facebook team, and we figured out like how to run it, and like everything was looking good except of that, like the project was written in C++, and we didn't have a lot of expertise of C++ in our team, and accuracy wasn't high enough, so it wouldn't go with our business needs as a company. Even for voicemails, accuracy was like less than 80%. So, but voicemails are pretty easier to have transcription because like it's mostly one person speaking without interruptions, and like in general, the messages are pretty simple and short. So after understanding that in order to train Wave to Letter model, we need to have a lot of like transcribed, labeled data, and it's also support of C++ project, which is not so trivial task. We were observing other possibilities, like what are other models that we could use, for example, besides Wave to Letter. So for after that, we figured out that there is Wave to Vec project. Wave to Vec project was built with FairSec inference. It's the library in order to run your model in inference pipeline, so it could be easily run on environment, and you will be just feeding via script like audio files, voicemails, voice calls, and you will be receiving a transcription. So Wave to Vec, like what is it special for Wave to Vec compared to Wave to Letter? Why we we just at first we wanted to try it, like to understand, you know, because there were a lot of articles that were announcing that Wave to Vec is pretty like is pretty mature model. Wave2Vec, the same as wave2letter, they exposed a lot of pre-trained models, and even pre-trained models for wave2letter, they were having not so high accuracy. And for wave2Vec, based on the information that we like found in internet, accuracy of wave2Vec was considered to be pretty high, like more than 90%. And it was looking for us quite promising. And also one thing that just took our attention, that it's written in Python. So supporting it and like understanding what's inside will be much more easier than working with C++. But creators of Wave2Vec projects, they use some kind of bindings to use the code that was written in C++ for Wave2letter project. So, and it appeared to be true. Wave2Vec pre-trained models that were exposed by FairSec team, they showed very good results in terms of accuracy. Like error rates were less than 8%. And it's something that just like, make us think that we could use it for production, because it's pretty good enough. And for voicemails, accuracies were very promising, and that's why we started on productionizing it. Because we've measured all metrics that we need, like performance and accuracy. I will talk a little bit later of what are the numbers for metrics are. And it gave us ability to adopt it for our needs. So just few words about how Wave2Vec architecture looks like, how it works like. So if you maybe know like BERT model for Google, it also has transformers inside. They are pretty similar in terms of ideology, Wave2Vec 2.0 and BERT, because they have transformers inside. And like the main difference that for income, Wave2Vec 2.0 model gets, since the signal is a continuous process, gets a continuous vector. And for BERT model, it's text, and the text is like finite, so like it's finite vector. So, and the model first processes the raw waveform of speech audio with multi-layer convolutional neural network to get latent audio representations of each frame, like 25 seconds each. These representations later, they fed into a quantizer as well as a transformer. So about half of audio representations for latent audio presentations, they are like about half of audio representations are masked before being fed into a transformer. So the transformer adds information from the entire audio sequence. Is what transformers do, and what makes this model special. That besides how accuracy and good context taking place, because transformer not looks like just into one word. It looks into the whole context, to the words that are situated nearby. Finally, the output of the transformer is used to solve a contrastive task. This task requires the model to correct quantized speech units for the masked positions. So it's the same as BERT does, like in the end. So like some words are marked as like unknown one, and the BERT model needs to understand what are for the like words that were masked, and then just to unmask them. So this is about Wave2Vec architecture, just like in general concepts. So, and what makes it so unique and like ready to use, that for Wave2Vec, you have a lot of pre-trained models that also are applied not only to English. They have pre-trained multi-language models that you could use for your system, and just like download it, make it run based on tutorial, understand what's inside, measure accuracy, try maybe to fine-tune it. Because for Wave 2.0, like the main thing about it is it like requires less audio, less labeled audio compared to other models, especially like to wave to letter. So it requires only like 10 minutes of your labeled audio for fine tuning of the model. So, and this fine tuning will give ability to increase accuracy of the model even more than like 90%. So it's very promising, and it's something that that worked for us as well. Besides the model, if you like have a good model which is ready for production, so and you like measure metrics, everything looks good, but it's just the beginning of the journey. Because besides of like running it locally or on dev GPU, it's just one piece of a puzzle. So you need to embed it into your system. So I will share how we did it for our system. Since accuracy of the model was pretty high for voicemails, it was just something that we needed to start with, because if you have like high accuracy, like we were using pre-trained model of wave-to-wake, and it enables us to think about that we could have this feature in our products for voice transcription, for voicemail transcription. So it's just a little piece that like a little piece of backend architecture, how like what's inside of our product, and like 3 pieces of AI. They are integrated via queues asynchronously, as you see on the screen, via voice orchestration service. So voice orchestration service is responsible for like maintaining all the data that is like connected to voice, like voice calls, voicemails. Once a voicemail comes in to voice orchestration service and it needs to have a transcription for that, voice orchestration service into the queue sends voicemail ID. And based on the voicemail ID, voice transcription orchestration service goes and takes the whole voicemail file and then sends it to our engine, to our model, in order to transcribe it. Once this process of transcription is finished, then transcription is sent back into another queue. We did it loosely coupled. So in case of like, if we need to like scale it and etc., so it will be easier. Also adding this with the queues will enable, for example, if, I don't know, if something goes wrong, for example, with transcription, we will not be affecting the whole general flow of the user. So it will not be a bottleneck for like general components and the flow which user experiencing once leaving a voicemail, and then like once leaving a voicemail for user one, and then user one like listens for that. So let's look to more details how it looks like. Like this is a sequence diagram for the calls that I just described. For voice provider service, it's a service who gives us back base 64 encoded data file. Transcription orchestration service is only responsible for integration via queues with other parts of the system, such as voice orchestration service, and sends the data for transcription service. Transcription service consists of 2 parts, 2 components. It's transcription service HTTP server and transcription service ML process. So the first one is responsible for getting this data and for its preparation, and the second one is responsible for transcription itself. Besides transcribing, right now we're also working on adding punctuation model, because voicemail, just after it's been transcribed, it's just like capital letters and not, I would say, user-friendly text, and not like the text that you would like to see as a business feature in your application. So that's something right now we're working on. Okay. So we covered components that were taking part into the integration and embedded into the system. But once you want to understand and to maybe like speed up, velocity of your model, and you're starting to think about that, we've came to ONNX. So what's that, like ONNX? It's an open source artificial intelligence ecosystems that gives you a lot of possibilities, very convenient and very easy to use. So why it's so cool? For example, if you have like one technology that you write, for example, like on TensorFlow, and then you want to run it like on different like kind of environments, platforms. So with ONNX, it doesn't matter which technology and framework you used before. You will just convert it to be compatible and running on NX runtime, and you could use and you can run it anywhere. On CPU, GPU, on your mobile device, in the cloud, it doesn't matter. So it's an open source free tool that enables you to pick up technology any like that is compatible with your needs. Also based on the skills that you have in the team, and ONNX give a big boost in terms of velocity for your model. So it also gave us this possibility. And for sometimes also, if we are talking about what is our deployment target, ONNX enables you not to be bounded just to GPU, because GPUs like are pretty expensive, and not always it's something that you could afford like as a startup, and etc. So it also have ability to run like on any environment you want, and gives ability to make clusters out of this environment. So, and in terms of development, if you have your working station is on CPU, you could run it on CPU. Then for production, dev, and RC, you could run it on GPU later. So it's like a cross multifunctional tool that gives you ability not to be bounded to any kind of framework. And it gives you ability also to run your model anywhere you want, and to scale it on anywhere platform deployment target you have. So this is all about ONNX. But in order to have this list of abilities, you need to convert your model to be compatible running on ONNX runtime. It's like a platform basis where you run your models. Sometimes converting to an NX runtime could be pretty challenging task, because it's a new technology, not widely used everywhere, and etc. But once you've done it once, for example, for your model, it will be easier to make it each time once you're going through the same process. Because, for example, for development, we are using PyTorch model, and we are working on it, modifying it. And then when it comes time for production, we are conversion script, converting it to an NX format and running it on CPU and GPU. So this enables you not to be bounded to any technology and to any deployment target. So let's go to the interesting part of numbers. As you see on the table, in the table, it's the data based on what model we've used and on what environment it was running. So our dev machines are more powerful than our production machines, and because for dev we have RTX 3090, and they are just awesome for the models. And for these powerful dev GPU machines, we had the response time, we had 47 voicemails, and we put an effort on having voicemails transcriptions for that. And we compared what is the total time of dev GPU to transcribe 47 voicemails. And for us, it was 19.5 seconds. It was just for pre-trained Wave-to-Vec 2.0 models that we embed to our system and made it run on our dev GPU environment. But after we figured out that ONNX is an amazing tool that we could benefit from, we made the same tests and measured it on Wave-to-Vec 2.0 ONNX. So, and it showed very amazing promising results. And for each voicemail, transcription time was 12.07 seconds. So as you see it, it's less for 50%. based on the previous results, which were actually like from the beginning okay, but with ONNX it started to be even better. But I also want to point on some details on that, like it's just one node, it's not even a cluster. So if you would like to add more nodes to the cluster, it will give you much more flexibility with that, because with ONNX you could just embed it to the configuration and run it. It's not just something complicated, and you will have ability to scale horizontally, which is very useful, especially once you're not like, I don't know, once you want to prepare for some load and you will start with the small, and then like a lot of users mails come and you would like to scale. So this is something very useful and promising to use as ONNX for production needs. Also, like based on the performance analysis, so what things like could be great, you know, like to improve and to work on. So sometimes, like based on the vocabulary size, like if the like user, you know, like what generally influence like accuracy of the model, like the speed of speaking, accents, noise, and etc. For most of the ICR system, it's the same for ONNX, like they are speaker independent, but previously it wasn't like that. So they are like once one person speaks and then another one, it doesn't matter, the accuracy will be in general like more or less the same. So let's talk about accuracy, how it's calculated. Accuracy is calculated based on this formula. For calculation needs, we were using Levenstein algorithm, and Levenstein library is available. It's open source, and you could use it like for any project you would like. So what are things that you need before measuring your accuracy? The first thing that you need is like your etalon, so original transcription with which you will compare. Without that, you will not have like any word error rates, because the data that you need for the formula, it will be absent. So as you see in the formula is S, D, I, and N. It's corresponding number of substitutions, deletions, insertions, and the total number of words. So this one is calculated based on the original text and the text that you received after making transcription of the voice call or voice mail or any audio. Okay. This is the table. It shows results that we've made. And we calculated for not only for our like Wave2Vec 2.0 that we adopted for Nextiva, but also with some different other like third-party providers. For example, with Motari, it's a third-party transcription provider that is used currently for Nextiva for voicemail transcriptions. And the average word error rate, as you see, it's like pretty high. So it's not like, it's not percentages, it's just like parts of one. So in percent, it's like 26%, which is pretty high, especially for voicemails. For Google API, it's 3.9%, which is like number one out of these three. And also for Wave2Vec 2.0, it's 7.3. So we are not far away from Google in terms of accuracy for voicemails, which is really awesome. And like having this kind of accuracy will help, you know, to embed the transcription feature to the application and wouldn't be, you know, ashamed of accuracy that users are getting. And also results like standard deviation also shows that like what is the level of stability of the model. So for Wave2Vec 2.0, it's not also so big, it's like more or less 7%. And for Google it's better, and for Motari like it's huge. So standard deviations shows that we don't have a lot of surprises in terms of accuracy. So it's more or less stable, and it doesn't vary a lot from the average rates. So this one we are very happy to share, and anyone who would like to use Wave2Vec 2.0 model will have the same results, because these models are pre-trained and free to use. You just need to understand what's inside and adopt it for your company needs. Another useful metric is RTF, real-time factor. It's something that we are not right now really concerned about, but we will be once we are making voicemail, once we are making online transcription. So real-time factor, it's the ratio of how much time you spend for transcribing audio and what is the total length of this audio. So for example, if the audio was 10 minutes and you transcribed it in 1 minute, then it will be less than 1. So you could say that you're compiled and you could assume that your model will be good for online transcription. But if this ratio is more than 1, then it's a place for improvement. So just you need to do something that your model should be faster. For our models that we are using right now for voicemail transcription and are planning to use for online transcription, it's less than even 1%. So it's super great. Results looks very good, and these are the ones that we received while converting Wave2Vec 2.0 in order to be compatible and run on NX runtime. So it's on the next runtime, we should, to say thank you that it gave such a big boost in terms of velocity for the model. Okay, so as a result, I would like to share that Wave2Vec model is easy to adopt. Creators of it make available a lot of pre-trained models which anyone could use, embedded to application, track results, fine-tune on less amount of labeled data. Also, a good thing to do is to embed and to convert, make Wave2Vec compatible and be able to run on NX, because it will open a lot of doors for any project. So scalability will not be issue, speed will not be issue, technology will not be issue. So it will give flexibility of picking those up for how your team would like them to be. So it's very convenient and something that anyone who wants to make production solution should definitely use. So what are next steps we are doing as a team? We are building a real-time voice transcription architecture. We've prepared already the model, measured RTF real-time factor that it's pretty, it's not so slow, has high accuracy, and it should be considered as a candidate for online transcription. Then we would like also to work and to think about integrating GPT-2 model. It's considered to be number 2 of the best existing models after GPT-3, but GPT-3 code is not available right now. So, but for GPT-2, we could easily embed it. It's free and open source. And also something that we are working on, it's training the model on Nextiva's data. We were preparing data for training, cutting it, labeling it, rechecking it, and we are right now ready for that, and we are working on it, and hopefully we will get even better results that I've shared with you. So I've also recorded a voicemail transcription example that how backend system works, if you have time for it, of course.
Okay. I would like to show you a technical demo about voicemail.
Okay, as you see on the screen, this is an architecture that we were talking about. And these are the components that we also were talking about today. I will just skip some parts. Okay. This is I'm taken into one of voicemail IDs for my account. Yeah, and with simple like feeding just this message ID to Kafka queue, as you see on the screen. I will be getting a transcription back. And here I will put the volume on, sound on, so you could recheck how it matches with original audio file.
And right now, so
our fathers brought forth on this continent a new nation, conceived in liberty and dedicated to the proposition that all men are created equal. Now that we are engaged in a great civil war, testing whether that nation or any nation so conceived and so dedicated can long endure, we are met on a great battlefield of that war. We have come to dedicate a portion of that field as a final resting place for those who here gave their lives that that nation might live. It is altogether fitting and proper that we should do this. But in a larger sense, we cannot dedicate, we cannot consecrate, we cannot hallow this ground. The brave men, living and dead, who struggled here have consecrated it far above our poor power to add or detract. The world will little note nor long remember what we say here, but it can never forget what they did here. It is for us, the living, rather, to be dedicated here to the unfinished work which they who fought here have thus far so nobly advanced. It is rather for us to be here dedicated to the great task remaining before us, that from these honored dead we take.
Okay, so as you see, it has pretty high accuracy, and the text is one like of the famous from the US history. I also want to show just like the last scene. It's what is the word error rate for our transcription model of the adoption of wave-to-wake model, and what it was like the word error rate for Mutari. It's third-party solutions that we used for Nextiva for voicemail transcription. Just executing. So as you can see, word error rate for the Mutari one was 15%. So it's not like so pretty high, but and it's not so low. So, and let's see what was the word error rate based on wave-to-wake 2.0 model. So as you see for wave-to-wake model, it's like 2%, which is awesome. And we see that the like adopting wave-to-wake pre-trained model gave us very good results, and it's also something that anyone could try to do. Pre-trained models are available and easy to use for anyone. You just need to get like used to technologies, more deeper understanding what's inside, but you don't need to like train it on your like GPUs or anything. It's already there, and the accuracy out of the box is quite promising. This is our team who worked on adopting this model for Nextiva and building solution for it. So thank you guys. And in general, thank you. I hope it was interesting for you, and waiting for questions, of course. I can't hear you. You're on mute.
Sorry, it happens. Yeah, thank you very much, and it was really interesting. I think we get to know so much about this model, and we have one question. Well, it's two questions in one. But if anyone has any others, please put it in the Q&A. I'm going to read it. It's from Eduardo Torres, and it says, can I use WAV2Vector 2.0 on an audio file with echo and ambient noise, for example, a conference recording, in order to get a clean transcription? Or it's easier to use another AI tool to clean the audio file and then use WAV2Vector?
Thank you for a question, very good one. So you could try to run it with even with ambient noise on it and like measure results. We had the same problem for noise, and like this is something that we were thinking about. Like at first you should try without even noise cleaning, but what we will be doing for our voicemails and voice recordings, for voice recordings especially, because voicemails are considered to be more clean, is that we will be using a separate model for cleaning noise. And if you're like interested on what is it a model, what is like noise cleaning model, it's also open source model. So you could reach to me directly, or I don't know, send a question. So I will reply with sharing resources for the models that we will be using for cleaning of the noise. But even if the audio is noisy, results of Wave2Vec 2.0, they are like pretty good even without noise filtering. But if you want to have everything perfect in the place, then it's better to have like a sample of the models. Yeah, of course, feel free to reach to me. I will be happy to share.
Thank you, Anna. We have some other questions. Can I read it to you?
Yeah, of course, of course.
Thank you. The next question is, did you do any pre-processing, such as filtering to reduce noise or to enhance voices?
Yeah, it's like relates to another one. So right now for voicemails, since for our company and for our company needs, they are more or less clean. We don't have it on production already, but we will for sure doing it for voice calls. It's in the process right now of adopting that, because once you're having like not only one model, but several models, you need to be sure that they are, you know, like they work as an ensemble of models. So they work in an effective way. And sometimes if you could parallelize the process, you should do that. But filtering, like removing noise, is something that is like the part of pre-processing. Also interesting thing that Wave2Vec 2.0 model, it consumes 16 kilohertz mono, and if you would like to run another data, another audio files on it, you should think about pre-processing. But up to what audio you're having in your company, there are a lot of Python libraries, also open source, that you could use and make this pre-processing. And as an example, you could use it in the same way as we did, like in two processes. The first one for agent is the one that prepares audio, and the second one that transcribes. So in this case, you will not be having situations that like you're doing it everything in one place, and it will slow down your architecture. Yeah, hopefully I answer your question. And if you want to have, you know, the link for a model, also feel free to reach.
Awesome, thank you. We have a couple of more questions. I don't know if we can have them. I know we are on time, but
of course.
Yes.
Yeah, of course.
Other question is, have you considered the case of having empty messages? For example, a voice note sent by accident where no words are said?
It's also a very good question. I like that. It's something that we worked on the last, I would say, months, like, you know, few weeks before, like before this presentation, while we were testing it, because like in our company, we don't have like, it's for AI team, it's only engineers. We don't have special, you know, QA members. So we are working on DevOps, CI/CD and everything, and engineering and QA by ourselves. So we are like, you know, as an independent city for that. And what we were doing, once transcription, for example, doesn't have audio, it will give you empty text. So before, like, just you know, how we solved it, and like I can say that it's like the best solution that could be made. After transcribing of the audio, we are detecting if there is a text there or not, and we are sending business errors to to front ends, to mobile, and later to desktop applications that we will be integrating with backend of our AI system. That in the voicemail we had no ability to find any, you know, like meaningful text. So it's something that we've done, but I assume that there are, you know, like another solutions that we also investigated. So there are separate models that will give you ability to understand, like, if there is some kind of like meaningful text inside of audio file, but it's also up to the cost for your velocity. If you are adding, like complicated models and you need to resolve them, and like also keep a track on them, like monitoring and other things. So it will give more complexity to the whole solution, and it will slow down response. So we've started from Zend, just with simple one. And if we had like, if you'll have, more cases that we need to cover, or feedback from users will be with, like complaints and etc. So we will be looking into adopting the model that detects if there is a text inside of audio or if it doesn't have. Yeah, hopefully I also answer your question.
Yeah, I think you do. Here are some people like Leonardo Paiva congratulating you. This was awesome. This is very detailed, and congratulations on that journey. And he's curious about the real-time transcription. What are the languages that are on the roadmap? And I'm willing to say this one too, because the next question is Nextiva targeting other language than English? So what are those languages?
Yeah, okay. So for right now, since, like we are more like department, like AI department, but we are also concerned, about business needs. So we don't want just, like to, we like math and AI, but we also want to bring value for the users, for the end users. And we are trying to think about that, during our, daily activities. So our current model, it's only for English. For existing customers and support that we now have, yes, it's for now only English. But as I shared before, for Wave2Vec 2.0, there is pre-trained model that is like that supports multi languages. It's also available pre-trained and open source, and anyone who would like, like to play with it, also, have ability to do that. I'm personally planning to play with it for Ukrainian, and Russian, like since they're my native languages. So, but like in terms of accuracy and like results, not for English languages, it's hard to say, because it's a big effort, that like to run this model, like have labeled data that you could compare accuracy, how it works, is it performing well or not. So besides the models that we right now adopted, there is another one, as I shared. So anyone who would like to onboard it, like check how it works. So it's something doable. And also, if you want a link for that, feel free to reach for me. So I will share that, because this model we were also trying to, like compare with the ones that was used for English. And but the one that was used for English, so it has like language model inside. So we used KNLM language model for that, and it had higher accuracy than multi-language model for English. But I'm not sure about the data and like metrics that were for other languages. So, but if someone is interested in having a link for that, so I'll be happy to share. And it's also something that you could run later on NX, because like on NX also gives ability for any AI team who would like to build their transcription system, or like any AI systems, that you could deploy their models, and you will have, and you don't need to worry about scalability, and it will boost the velocity of your model a lot.
Thank you, Anna. I think you're gonna get very in touch with many of the attendees today because it was really clear what you show us. The last question is, if another language can be translated, is there the ability to translate the text from that language to English?
Yes. Besides speech to text, the model also can perform another task, such as translation. But for our business needs, we right now don't need translation, but pre-trained models also have this ability. We were not digging into that, because from the business perspective, it's not something that we needed to concentrate our full attention on.
Great, thank you very much. Well, I think that's it. But we were really, really amazed by this presentation. I personally will contact you too, because I have a project in natural language processing, but I think there's some guidance you can provide to me, and so I think
Of course.
you're not gonna we're not gonna be the only ones. So thank you very much, Anna. Thank you to the team
Thank
of
you.
Nextiva.
Thank you.
And thank you to everyone who joined us today. We will be having other talks in the future, so be there for them. There's gonna be many other topics. And thank you very much, Anna, once again. We'll see you later. Good night.
Thank you. Bye-bye. Thanks for having